Hi, I had a specific question about the combustion of methane. And so I thought I'd walk you through something like this. And instead of doing 60 and 24, I think what I'll do is I'll do some other number. And so you guys are doing 60 and 24, but I'll do 20 and 25, something like that. But let me just walk you through the first one there. So I'm going to come over here. Let me get out of this. I'm going to go to the molecules. I'm going to combust methane. And the first one that I had was 3 and 7 there. So let me just talk you through this, okay? So the key thing is I want to look at the ratios that I have up here. And so the way that I would interpret that is think of it like a recipe. I need 1 mole of CH4. I need 2 moles of O2, and that's going to form 1 mole of carbon dioxide and 2 moles of water. And so let's just look at these individually. By looking at the CH4, I have 3 of them. And so by looking up here at my recipe, I got 3 CH4s. So if I have 3 CH4s, then that means I have enough to run the reaction 3 times. Right? Because I've got 3, the recipe only calls for 1, therefore I've got enough to run 3 times. Well, 7, if I've got 7 O2s, then that's enough based on this up here. I can't quite run the reaction 4 times, but I can run it 3 times. And so therefore, how many times am I going to actually run the reaction? Well, 3 times, because I can, based on the amount of methane, CH4, I can only run it 3 times, and based on the amount of oxygen, I can only run it 3 times. So therefore, I'm going to run this reaction 3 different times. Well, each time I run the reaction, I'm going to form 1 carbon dioxide. So therefore, if I'm running it 3 times, I should have 3 products. And if I'm running the reaction 3 times, each time I'm going to form 2 waters, and so therefore I need to take 3 times 2, that's 6 H2Os. Now that leaves only 1 O2 that I didn't yet react. Okay, so now talking through that now, I'm going to come back here so we can make sure that we remember the reaction. Make sure I click combust methane. I'll come back here. Now I've got 20 methane and 25 O2s. And so I've got 20 methanes, CH4s. I've got 25 O2s. Well, if I have 20 methanes, based on the recipe, how many times can I run the reaction? Well, each time I run a reaction, it requires 1 methane. So therefore, I can run it 20 times. Well, if I have 25 O2, how many times can I run the reaction? Well, each time I run the reaction, it's going to require 2 O2s. And so therefore, I'm only going to be able to do half of 25. And that's not even a whole number. I'm only going to be able to do 12 total times of reaction. So how many times can I run the reaction? 12 or 20? Well, obviously, I'm going to run out of oxygen, so I'm going to run this reaction 12 times. So if I run this reaction 12 times, then each time I run the reaction, how many CO2s am I going to form? Well, each time I run the reaction, I form 1 CO2. So if I run it 12 times, I'm going to form 12 CO2s. And so what I form on the product is I'm going to form 12 CO2s. Well, each time I run the reaction, I form 2 waters, and so if I run it 12 times, I'm going to form 2 times 12, which would be 24 waters. And so now the question needs to be, how many leftover do I have? Well, I know I have 1 O2 that's left over. I have 1 O2 that's left over. But I also will have some CH4s left over. Well, I know I could make 20. Well, now let's see. Okay, I ran the reaction 12 times. If I run it 12 times, how many total methanes will that require? Well, obviously, from the reaction, it tells me 1 methane is required each time I run the reaction. If I run the reaction 12 times, then I'm going to use 12 CH4s. So therefore, that's going to leave 8 CH4s that are left over. And so you'd say 8 CH4. I hope that makes sense.